Hey everyone, in the second part of the SNS series, and we're keeping to the topic of progressions, we're looking at the second progression that you need to know, which is the geometric progression, or our favorite GP for short. So what is geometric progression? We've already learned about the plus and minus series, right? Increasing and decreasing series based on a common difference. However, in your geometric progression, we're looking at multiplying and dividing the remaining two operations that we haven't discussed yet. So what do I mean? Let's take a look at a few examples. We have, let's say, a very simple example: 3, 6, 12, 24, 48. All right. So if you're going to look at it very simply, plus 3, plus 6, plus 12, plus 24. Okay, one thing you notice that, okay, the difference between two terms is double of the difference of the previous term. So plus 3 times 2 is plus 6 times 2 is plus 12. However, a better way of seeing this is noticing that, hey, from 3 to 6 is times 2, from 6 to 12 is times 2, 12 to 4 is also times 2, 24 to 48 is also multiplied by 2. So this is also an example of increasing geometric progression. Another possibility is maybe not increasing, but actually decreasing, right? For example, we have, let's say, start off with 8, then we have 4, and then 2, 1, and half. So you know that this is basically divide by 2, divide by 2, divide by 2. We can also introduce negative ratios, right? Negative constants, where we multiply by negative constants. So let's say we have like 2, then we have minus 6, and then 18, minus 54. So you notice from here to here is times 3, times minus 3, sorry. From minus 6 to 18 is times minus 3. And then from 18 to minus 54 is times minus 3. So I think it's quite obvious to how we find a general formula. Alright, so let's say we start the general formula of a specific term. So un. So you notice that it's always a multiple of the first term, right? So if you notice, it's the same idea. The second term multiplies by 1 times of 2. The third term multiplies 2 times of 2. The fourth term multiplies 3 times of 2. So what happens is that we have the first term 3 and multiplied by the common ratio 2 to power n minus 1, because you multiply 2 3 times. So for the fourth term, you multiply 2 times for the third term. So it's basically n minus 1. Same thing for the second one. We start off with 8. The common ratio is half. Then again it's n minus 1. The third term, first term is 2. The common ratio is minus 3. Therefore power n minus 1. So you notice the thing n minus 1 is basically a common feature between arithmetic progression and a geometric progression. Therefore we kind of have this general formula, right? For any term in any geometric progression, we have a, the first term, common ratio r, a phrase that I've been saying a lot, power n minus 1. So a equals to first term, then r equals to the common ratio. All right. Now, what about the summation of a geometric progression? All right. So a series of n terms. So let's use two other examples, maybe the first and the second example. So in the first example, we have 3, 6, 12, 24, and so on. Then in the second example, we had, what was it? Oh, I can't remember. Whatever, let's make a new one. 4, was it 3? Wait, never mind. 3, start with 2, minus 6, 18, minus 54, and so on and so forth. Terrible memory. Anyways, so we know that if you try to use the same methods before, right, you notice you try to pair them up, the first and last term, the second and second last term, you notice you get very different answers. You get 27 and 18. So it's not that useful. So we can't really do that, right? Is there another way? So let's try to use a general formula style, all right? So let's say for any sequence, right, we have the following, which is basically a plus ar plus ar squared plus ar cubed, and so on. What I do is, okay, let me multiply that by r, and I get ar. Okay, from here is ar n minus 1. Okay, AR squared plus AR cubed plus AR power 4 plus all the way to AR power n. What do you notice? If I take Rsn minus Sn, what I notice is basically a cancellation of terms, right? This minus this, this minus this, this minus this, this minus this, and so on and so forth, and this just get minus until I'll get AR power n minus a. Then I simplify, right? I get Sn equals to Arn minus a over r minus 1, and then I therefore get Arn minus 1 over r minus 1. Obviously, r cannot be 1, right? Because r equals to 1, then this side will become 0. So this formula is only valid for r not equals to 1. Okay? So there we then have the general formula. All right, make sure I write that. We're gonna write that in green now so that we can easily see Arn minus 1 over r minus 1, which also equals to a1 minus r power n over 1 minus r. Basically just taking the negative of both sides. So let's apply this. All right, let's say we want to find the n terms, right? So for this one, if I want the summation of n terms, it will be 3 Rn minus 1. So r is over here is 2, so 2 power n minus 1. Below is 2 minus 1 equals to 1, so this will be my final answer. For the second one, first term will be 2. R is now minus 3 whole thing power n minus 1. Below will be minus 3 minus 1 to give us minus 4. This will then lead us to half 1 minus 3 power n, and that will be the summation of n terms, or the series of n terms. So in summary, right, in general, the following formulas for our geometric progression. So the gen formulas. So the term will be a r power n minus 1. So if you don't like the brackets, it will simply be this. Then for the summation of furthest n terms, it would be a Rn minus 1 over r minus 1 equals to a 1 minus r power n over 1 minus r, where over here, importantly, r cannot be 1. All right. Obviously, if r equals to 1, it's basically just n times a, right? Because if r equals to 1, if the combination is 1, basically the first all the way to the last term would be the first term, right? Because a plus a plus a plus a, so a plus a n times, so it will be a n. So this would be when r equals to 1. All right, so that's logical. So again, a is first term, r is the common ratio, and there we have it, the geometric progression for our S and S.